All right, going over the probability test review. Number one, we've got two sets, set A, set B, and then we have the universal set. And we want to answer the following questions based on those sets. So part A says, are these events mutually exclusive? So we want to look at A and B and see, can you be in A and B at the same time? Yes or no? If you cannot be, then they would be mutually exclusive. If you can be, then it would be inclusive. So look at A, look at B. Do they have any overlap? Anything that's the same? Can you be in both of them? Look here. We've got 2 in both of them. We've got an 8 in both of them. So these events are not mutually exclusive because they have numbers in common. All right, part B says find the intersection A intersect B. This symbol, the upside down U, that's the intersection. It means that these numbers have to be in both A and B. So A intersect B is the numbers that are in both. Well, we already pointed 2 of them out, but I'm going to go through and just look at all the numbers just so we make sure we don't miss anything. So starting with A, we've got 0. I don't see a 0 in B, so I'm going to cross it out. 2, I see in both of them, so I'm going to list 2. 4, I don't see in both of them, so I'm going to cross it out. 6, I don't see in both of them. 8, oh, I see an 8 in both, so we got 8. And then 10, I don't see in both of them. So 2 and 8 are the only numbers that are in both A and B. All right, C, find A union B. That's what the upside down U stands for, the union, and that's for everything that's in A, as well as everything that's in B. So you just have to be in A or B in order to be in this group of people. So we're going to list everything in A and then everything in B. So we've got a 0, a 2, 4, 6, 8, 10. And then the things from B, I have 1. We've already listed 2. We don't need it twice. So 3, 5. I've already listed 8. And then 11. So that would make up the whole set A union B. That means that these numbers can be found in either A or B. All right, a complement. Looking at the complement means everything that's not in A. So we look at the universal set for this. So to find a complement, it's everything that's not in A but is in the universal set. So I'm going to go through and just cross out everything in the universal set that is in A. So I've got a 0, I'm going to cross out 0. 2, cross out 2. 4, cross out 4. 6, I'm going to cross out 6. 8, cross out 8. And then 10, I'm going to cross out 10. So now everything that's not crossed out would be an A complement. So I have 1, 3, 5, 7, 9, 11, 12, 13, and 14. All right. Then we go to part E, and part E wants the intersection of A complement and B complement. So let's first find B complement. A little extra practice here. B complement, everything that's in the universal set that's not in B. So let's cross them out. We've got a 1, cross it out. 2, cross it out. 3, cross it out. 5, 8, and 11. So everything that's not crossed out is B complement. So I have 0, 4, 6, 7, 9, 10, 12, 13, and 14. So now to find A complement, B complement, A complement intersect B complement, that's everything that's in both. It has to be in A complement and in B complement. So is there a 1 in B complement? No. Is there a 3? No. Is there a 5? No. Is there a 7? Yes, 7's in both, so we'll list that. Is there a 9? Yep, 9's in both. Is there an 11? Nope. Is there a 12 in both? Yep. How about 13? Yep. And then last 14? Yep, in both. So here we've got everything that's in A complement and B complement put together. 7, 9, 12, 13, and 14. All right, number 2, very similar. We're looking at F and G. First question is F intersect G. Remember, this means it has to be in both F and G. So I'm going to look at everything in F. 31, is it in G? No. 42, nope. 53, nope. 64, nope. So there's nothing in common between F and G. So this would be the empty set. It means it has nothing in common between F and G. What about F complement intersect G? Well, let's find F complement first. F complement is everything in the universal that's not in F. So let's go through, cross it out. I've got a 31 here, so I'll get rid of that 31, a 42, a 53, and a 64. So now let's list everything for F complement. We've got 15, 25, 35, 45, 55, and 65. Now to find F complement intersect with G, this means it's in both F complement and G. So in G I've got 25. Do I have a 25 here? Yep. 35, and there's our 35, so it's in both. How about the 45? Yep, 45 is right here. And last, check for that 55, and it's right here. So those 4 numbers, everything in F complement intersect with G. So it was everything in G was in F complement. Number 3. We're talking about a survey of people, and we've got this Venn diagram over here that shows us everything. And I've actually already filled in a piece, but I'll tell you how to find it. This 5 right here. We have surveyed a total of 60 people. Well, within the Venn diagram, if you add them all up, it's only 55. So that tells us that 5 people were not surveyed. So if you added 17, 4, 10, 1, 8, 2, and 13, you'd get 55. So these 5 leftover people said that they didn't have an Apple, a Dell, or an HP. And we use that for Part A. Part A, find the probability that the person has owned none of these computers. So the probability you've had none comes from those 5 people who said they had none. So 5 people out of the 60 total surveyed said, I never owned any of those computers. And so that's our probability, which reduce your fraction. That is 1/12. If you see these as decimals, that's also another way to write it, as a fraction or a decimal. So be familiar with seeing it both ways. I know we kind of go back and forth, so that could be 1/12 or 0.0833. Just be comfortable with both. B, what is the probability that the person has owned an Apple and a Dell computer? So this is anybody who's owned both Apple, here's all the apples, and a Dell. So we're looking for the intersection between these two. Notice here, this is where they overlap in the center. We have 4 people here, and we have 8 people here. Because it does not explicitly say what is the probability that the person has owned only an Apple and a Dell, we're going to include these 8 people who have had all 3. So the probability of an Apple and a Dell would be the 4 plus 8, so 12 people total out of the 60 surveyed. And when we simplify that fraction, we get 1/5. For C, what is the probability that the person has owned an Apple or a Dell computer? So this includes everybody who has had either an Apple or a Dell. So that's this whole piece here. So we're going to add up 17, 4, 10, 1, 8, and 2. When we add all those up, we get 42 people who have had an Apple or a Dell. So that would be 42 over 60. And when we simplify that fraction, we get 7/10. Last, part D, asks what is the probability that the person has owned all 3 computers. So you have to have all 3 computers, and that comes right in the center of our Venn diagram because that's the overlap of all three types of computers. So if I put them in colors here, notice that 8 is surrounded by all of our colors. This is the amount of people who said they had all three. So my probability of all three is 8 people out of the 60 total surveyed, which is 2 out of 15. All right, moving on to the back side of the page, starting with number 4. Here we're dealing with conditional probability. This line here is read as given. And with conditional probability, we've got this formula, the probability of B given A is equal to the probability of A and B over the probability of A. So we'll use that for these problems. These problems give us the probability of B given A. This one gives us the probability of A and B and asks us to find A. So we're going to take these two numbers and plug them into our formula and solve for P of A. So we've got probability of B given A equals P of A and B over P of A. And we're going to, here, probability of B given A is really 0.48, which is equal to the probability of A and B is 0.31 over probability of A is what we want to solve for. Here, we can put 0.48 over 1 and just cross multiply. So I get 0.48 times probability of A equal to 1 times 0.31 is just 0.31. And then to solve for P of A, let's divide both sides by 0.48. And we get that the probability of A is equal to 0.64583. So we're just using the formula to solve for the missing piece. All right, number 5. It only gives us one number. It says if probability of B given A is 0.48, but then it gives us this, and events A and B are independent, what is the probability of B? So here we need to understand that when we have probabilities and A and B are independent, the probability that they both happen, so the probability of A and B, is equal to the probability of A times the probability of B. This is really important here. So we're going to use that and plug that in to our formula. So if I've got the probability of B given A equals probability of, instead of A and B, I'm going to write A times the probability of B over the probability of A. When we do this, notice on the right-hand side, my fraction has the probability of A in both the numerator and the denominator. So in that fraction, the probability of A cancels out. And we're just left with probability of B given A equals the probability of B. So if I'm told that the probability of B given A is 0.48, and I know that that's equal to the probability of B, then the probability of B has to also equal 0.48. And there we go. All right, number 6, if the probability of cars given males equals 0.24 and the probability of males is 0.57, find the probability of cars and males. Again, we're setting it up. Probability of cars given males equals the probability of both. I'm going to do C and M for cars and males over the probability of males. Plug in our numbers, so cars and males is 0.24, which is equal to, we've got our unknown, the cars and males, C and M, over the probability of males is 0.57. That's kind of sloppy. Sorry about that. Cars and males. All right, again, we can cross multiply. So on the left side,